Welcome back to week 6 of the Containment Seal mini-series. This week we will explore all dual seal options and present a case that a pressurised dual is not the most expensive option when considering which dual seal plan to specify. One of the key drivers for the popularity of containment seals was the low purchase cost. It was, and probably still is, generally perceived that little to no sealing systems are required. Even if we do introduce a Plan 75 or Plan 76, they are significantly less expensive than the equivalent dual pressurised sealing plan. However, the purchase cost largely ignores the installation and ongoing costs when implemented correctly and safely. One major consideration for the selection of a piping plan are the utilities that will need to be connected to support the chosen plan. The cost, availability and practicality of these utilities are often ignored on new build projects and have to be carefully considered on brownfield retrofits. However, they will have significant impacts on the piping plan selection. If a nitrogen supply is not available, the option of Plan 72, 74 or Plan 53A may need a separate nitrogen generation system or certainly a local bottle installing in the case of Plan 53A. None of the other piping plans require nitrogen as part of a constant supply. Another factor which is also often overlooked is the level of instrumentation. Whilst instrumentation costs have come down or remained static for a large number of years, the cost of wiring these into the plant control systems has become more costly due to management of change controls and control system modifications. If we start to analyse the typical purchase costs by the seal vendor, but also start to consider the instrumentation installation and additional services required, it paints a slightly different picture to the overall costs. If we consider a standard 50mm 2-inch dual seal upgrade from a single seal on a typical application at less than 100 degrees centigrade, 210 degrees Fahrenheit, we get the above purchase costs for the supporting system only. The mechanical seal, whether an arrangement 2 or 3, are quite similar, but a non-contacting containment seal design would be marginally more expensive than a pressurised dual. So the purposes of this comparison, we will assume that all are equal and remove from the equation. Obviously, locational differences globally and currency exchanges need to be considered, but for the example shown, we will assume that this is typical of the United Kingdom, and the conclusion of costs will be given in US dollars and euros during the conclusion. One could also argue that client specification will significantly adjust these costs, and I would not disagree. The influence of higher levels of specifications will tend to push these costs upwards. However, if a Plan 53B system needs to be manufactured from pipe and not tube, it's also likely that this will apply to the other piping plans. So all costs become relative in terms of a comparison with the baseline datum being pushed upwards. In general, customers take a Plan 53B with only one instrument. More can clearly be added if needed for 4th edition compliance, but we still find operators are specifying 4th edition with a fixed alarm strategy which negates the need for a temperature instrument. However, in reality, the main amount of cost is pulling a cable to the pump location and hooking this up into the plant DCS. Again, costs will vary significantly from region to region and whether this is onshore or offshore, but the concept is simple for an operator to follow, and they can substitute their own numbers into the equation. Hooking up a plant nitrogen header to a pump, again, can be costly and will depend on plant to plant. In some cases, a nitrogen header is not even available, and costs to do this can run into many multiples of what has been specified above. The costs displayed assume that the nitrogen header is at the pump location, and this is just an interconnection cost. Typically, in offshore locations, nitrogen headers are not even installed, and this drives a different selection of piping plan due to available services. This is the cost of running interconnecting, piping or tubing to and from the cooler. Most operators, not all, are adopting tubing due to its flexibility and lack of hot work required in the case of a retrofit into a live plant. In some instances, it will not even be required, but we are basing this on a worst-case scenario of the Plan 52 and Plan 53A selection. Clearly, it may be an option if we can dissipate the heat from the seal without the need for cooling water, and these costs could be discounted. In retrofit upgrades, the cost of running a flare line to an auxiliary system is significant. Most refineries and petrochemical facilities will insist on welded pipe for flare systems and will simply not allow tubing. Again, this is client specific. It can sometimes be impossible on a running live refinery or petrochemical facility to tap into this flare header. Unless there is a convenient connection point in the flare system, costs will be very high if piping runs are long to get to the pump. This could be a distance away from the main plant, just the same as the nitrogen header issue as previously mentioned. So when we total everything up, the cost of the seal and auxiliary system is only a fraction of the cost of a dual seal upgrade when we consider the total installation cost associated with the chosen piping plan. There is a market perception that a Plan 53B is the most expensive solution. However, when considering the cost of all the hookups and services, the Plan 53B is actually one of the lowest installed costs and has been proven on many seal contracts to be more reliable with lower whole life costs than containment seals. To start the conclusion, operators often do not consider the overall installed and operational cost of systems and merely compare the upfront hardware cost. Potentially a Plan 54 can offer the lowest cost solution. However, this is dependent on the level of specification and complexity of the system and is a far deeper discussion point with too many variables. If highly specified, they can be the most expensive, and there certainly needs to be a consideration for the cost of running a power cable to the pump head with ongoing electricity costs. Plan 53A, seal reservoirs with screwed connections, is shown. Many users opt to upgrade to flanged connections on hazardous services. There are also many users who prefer standoff flanged level gauges, and flanged bottom reservoirs are also available. The additional cost of such items rapidly increases the cost of the 53A unit, and the price then becomes comparable, or in some instances more expensive than the equivalent 53B plan. Plan 53A will also have a greater installation cost in that it requires connection of at least 2 instruments and connection to a nitrogen service. There is a common perception that Plan 53B is relatively low cost. Bladder accumulators are mass-produced and effectively off the shelf from most suppliers. However, all the ancillary instrumentation and cooling has to be incorporated into the system package. These ancillaries are normally mounted onto a panel on a stand. With a 53, these components are mounted directly onto the vessel, and as a result, Plan 53B systems tend to be more expensive than a standard Plan 53A. However, with no connection required for a plant nitrogen system and potentially only one instrument specified, the installed cost is probably about the same as a standard 53A system. 53C is potentially the highest level of pricing. Effectively, this system has the same cost as a Plan 53B, but with the complexity of the piston accumulator replacing the bladder accumulator. However, with few instruments and no external services, the 53C can be surprisingly competitive, but can suffer with reliability issues on contaminated services. So buyer beware. Arrangement 2 plans require a flare connection, and the cost of the flare header can be very significant, which is different from plant to plant and region to region. Clearly, this is just a comparative illustration, and we would urge anybody who is involved in specifying seals and systems in a modern day plant to fully consider the alternatives to what is perceived a low-cost installation with respect to containment seals. We urge you to do your own cost analysis for your dedicated region, as it will even differ from pump to pump in a specific plant due to available services and the location of the equipment. Another misconception is that containment seals have zero ongoing maintenance costs. However, there is a growing realization in the industry that containment seals need to be tested periodically for integrity to ensure safe working practices in the plant, and this does indeed have a cost, not just for carrying out the test, but also potentially a loss of production cost as the pump has to stop. If you factor in this best practice cost, then containment seals have no benefit in terms of operational costs when compared to dual pressurised plans. Tune in next week for the next session where we consider carrying out your own safety risk assessment when considering the implementation of containment seals to add to the cost analysis discussed this week.